Okay, so these examples are already in echelon form. What I want you to do is use back substitution to solve these systems. So again, this is an echelon form because we have ones down the diagonal and we have a 0x term in the second equation. So it's in a triangular form with ones down the diagonal, and I can already see I have half of my solution here. I already know, because it's in echelon form, that y is equal to -3. So that's great news. What I really need to do is find out what x is. So to solve for x, I take the first equation, x plus 4y equals 5, and I plug in -3 for the y, because I am sure that y is equal to -3. So now I'm going to solve this equation. We have x minus 12 equals 5. I'd like to add 12 to both sides. To isolate x, we get x is equal to 17. So my answer is 17 comma -3. So for our next example, we have 1 in front of the x, we have a 0 below it, but in our diagonal, we have a 0 here instead of a 1. Well, that happens sometimes. When you're using transformations and you're trying to get the y to be all by itself, sometimes it accidentally goes away. And you get something like 0 equals -3. Well, I can't tell you what y is equal to because y doesn't have a variable right there on the second equation. This happens sometimes. But just when we were solving, equations in previous algebra classes, if you ever have a number equals a number and it's not true, do you see that this is not true? 0 does not equal -3. That is just absolutely not true. In this case, if you ever have something that is absolutely not true, because it has no variables, it's just a number statement, your answer is simply going to be no solution. All right, in our third example here, we have x plus 4y equals 5 and 0 equals 0. Again, you have a 1 in front of the x. You have no x's below it, which is great, but you don't have a 1 here. Again, you were trying to get a 1 there, but it didn't work out. And so you have a number statement again. This is different because this number statement actually is true. Okay, so because this is true, this tells us we're going to have an infinitely many solutions. Now, I can't just leave it at I have a lot of solutions. I actually have to tell you what the solutions are. So the way we're going to do this is similar to the way we did on the previous page. We're going to let y be any number, and then we're going to solve for x. This is going to get me an ordered pair in terms of y. So y is going to be y, any number y. To solve for x, I have x plus 4y equals 5. If I use transposition, I pick up the 4x term and move it to the other side. It simply changes sign, everything else stays the same. So x is equal to -4y plus 5. So in the x spot, I'm going to put -4y plus 5, comma, y. And that's going to be the answer for every possible solution. If I plugged in y is equal to 1, y is equal to 2, y is equal to 17, it doesn't really matter what I plug in, I'm going to get a solution. How many solutions are there? Well, there's an infinite because I can plug y in for any number that I want. So that's how you, if it's already in echelon form, that's how you use back substitution. 3 examples, a unique solution, a no solution, and an infinitely many solutions. Next, we're going to talk about row transformations. I need to teach you how to get from a system of equations, just a random system of equations, to an echelon form so that we can use back substitution. So we use transformations to change a system of equations to echelon form. So to solve a linear systems of equations, we will use the properties of algebra to change or transform the system into a new, simpler system of equations. The following are the 3 allowable transformations. The first one, you are allowed to interchange 2 rows. The notation that we're going to use is R1 interchange with R2, which is like a double arrow. And the simple thing here to do is you just take the first row, which is just the one on top, and the second row, and we're just going to switch them out. So I have 1x minus 4y equals 1 in the first row now, and then 2x plus 3y equals 12 on the second row. Now this was helpful because I really like that 1 up there anyway, right? So that was one way to get a 1. The second row operation that you're allowed to do is multiply a row by a non-zero number. So if I want to, I could take 1/2 times row 1 and put it back into row 1. So what I'm doing there is I'm basically just taking everything in row 1 and I'm going to multiply it by a half. I like to put it on every single fraction so I remember that I'm doing. A half of 2 is just 1x. A half of 3, well that's 3 halves, y. And a half of 6, that's 3. What happens to row 2? Well, there was nothing in this directions that said anything about row 2. So row 2 is just going to stay the same. Negative 4x plus 6y equals 10. So I've changed that system to be a new equivalent yet simpler system of equations. Okay. Why was this helpful? Well, I was trying to get a 1 up here. So remember, to be in echelon form, I like 1s down the diagonal. So both the first one and the second one actually helped me to get 1s up in the first position. Now this third row operation is a very important one, but it's a little bit trickier than the first two. We can multiply a row by a non-zero number and then add that product to any other row. So let's see, we have a row 1 here and a row 2 here. And this is saying I take negative 4 times row 1 and add it back to row 2. So if I'm going to take negative 4 times row 1, that means every single coefficient in the first row is going to be multiplied by negative 4. Now I'm going to use a space over here to do my work. So I have negative 4 times x is negative 4x. Negative 3 halves times negative 4. A lot of times students have a hard time with fractions, but this fraction isn't that bad. You're just going to multiply the tops. Negative 3 times negative 4, that's positive 12. So I was multiplying these tops, and then divide by the bottom. So 12 divided by 2 is 6. 6y. And then 3 times negative 4, that's negative 12. So underneath, so this is negative 4 times row 1, and now I'm going to add row 2, and I'm just going to put row 2 right up underneath it. And that's going to get me 4x minus 4x is 0, 6y plus 6y is 12y, and negative 12 plus 7 is a negative 5. So what happens here is the second row is the one that's being changed. Notice I put negative 4 times row 1 plus row 2, put it into row 2. So row 2 gets changed, and now that's going to be 12y equals negative 5. What happens to row 1? Row 1 stays the same. Okay, so those are the 3 transformations you're allowed to do. Talking about the goal of echelon form here, we have 4 steps. The first step is to try to get a 1 up in the first equation and the x spot for the coefficient. Okay, once you get that, the other numbers, it doesn't really matter what the numbers at that point are. You're going to first try to get a 1 there. And we're going to talk about exactly how to get a 1 in a minute. On step 2, then you're going to try to get a 0 below that 1 in the second equation for the x. You can write 0x, but it's kind of silly to write 0x, so normally we just don't write that at all. For step 3, after you get the 1 for the first x and a 0 for the second x, then we're going to focus on the y. Then I want to get a y to have a coefficient of 1 in the second equation. Once you have it in this form, we have now echelon form. After step 2 is over, it's now in echelon form. Okay, so what do you do next? Well, you're going to use back substitution to get an answer either in an ordered pair, or it quite possibly could be no solution. So those are the steps. Get a 1, get a 0 below it. Get a 1 for the y, and then back substitute. So the last thing we need to discuss is how do you get zeros and how do you get ones. So there's the three transformations I can use to get zeros and ones. If I switch to rows, that sometimes helps me to get a 1. For example, in our first case here, if I'm trying to get a 1 and I have a 1 right here, but I want it to be in the first row, well, I can just simply exchange the two rows. So I have x minus 4y equals 1 in the first row and 2x plus 3y equals 12. That's if there was already a 1 there, then I can use that to my advantage to get a 1 exactly where I want it. That would be like in step 1. The other thing I can do to get a 1 would be to multiply the whole row by the reciprocal. So let's say I'm trying to get a 1 where the 3x is. The reciprocal of 3 is 1 over 3. So if I take 1 over 3 and multiply it by row 1, by the way, what happens to row 2? Row 2 stays the same. If I take the reciprocal, 1/3, 1/3 times 3 is 1x. Negative 2 times 1/3 is negative 2/3. If you want to think of it as divide by 3, you can do that too. Equals 6 divided by 3 is 2. So did I successfully get the 1? Yeah, I did. So multiplying by the reciprocal of the term that you want a 1 in is a very fast way of getting a 1. Next, we're going to learn how to get a 0. To get a 0, that's the step where you multiply the opposite of the number of the row with the 1 in it and then add it back to the row you were changing. Okay, so in this case, to get a 0, you should already have a 1 somewhere, and I do. I already have a 1 in the x spot. So what I'm trying to do is I'm trying to get a 0 for the negative 6x. That's what I want. Okay, so to get that, I'm going to take the opposite of the negative 6, which is positive 6, and I am going to multiply that by the row with the 1 in it, which is row 1, and add it back to row 2. So I'm going to basically take a 6, a positive 6. Remember, it's the opposite of the negative 6, so that's why we're doing positive 6. So I'm going to multiply that to the whole first row. So I have 6x. Half of 6 is 3y equals 30. What happens to the second row? Well, this is just my work, but I'm just going to be doing it off to the side here. So I'm just going to write it up underneath it. The 6x minus 6x, when I add the two equations together, adds to 0. Then I get minus 1y equals 39. So I manipulated row 2. So this turns out to be negative 1y equals 39. What happens to row 1? Row 1 stays the same. Okay, so this is how you get a 0. Did I successfully get a 0 here? Sure I did, because those x's added to 0, and I forced that to happen. I took the opposite of negative 6, which is positive 6, multiplied by the row with the 1 in it, and add it back to the row 2.